The real numbers are an ordered set. What this means is that we can take two different real numbers and compare them. We can look on the real number line and see that one is less than the other one and make some comparison between them. For example, if I compare 2 and pi, 2 is less than pi because 2 is to the left of pi on the real number line. Once we start thinking about the ordering of real numbers, we can start to think about intervals of real numbers. Intervals are nothing more than sets of contiguous real numbers. What I mean by that is unbroken regions of the real number line. So for example, I could talk about the set of all real numbers that are at least 2 and at most pi. In this case, I'm thinking about all the real numbers x that are at least 2 and at most pi. So they form an interval or a contiguous region on the real number line. I can write those x in terms of inequalities. I can say that 2 is less than or equal to x. That captures the at least 2 part of the sentence. And I also require that x is less than or equal to pi. That captures the at most pi portion. We can write an inequality, or rather a pair of inequalities like this, as a compound inequality. All at once, we can say that 2 is less than or equal to x, and x is less than or equal to pi, and we just combine that into one compound inequality. We're really describing a set of numbers. That's the set of numbers that I've shaded here in red that includes 2 and includes pi and everything in between. And we write that in interval notation, which is just a convenient way to describe that set. First, we'd write a bracket, 2, pi, and then a bracket. The bracket here is indicating that I'm including equality here, both 2 and pi. So this is the set of all real numbers that includes 2, everything in between that all the way up to pi and includes pi. If I don't wish to include, I could change that. And of course, that changes the notation. So for example, I could look at the set of all real numbers that are greater than 2. I've changed the wording here, but still at most pi. So now I'm talking about x, which are strictly bigger than 2. I didn't include, or an equality there is missing now. And I still want x less than or equal to pi, at most pi, so it can equal pi. As a compound inequality, I'm saying 2 is less than x and x is less than or equal to pi. In interval notation, I just modify the notation on the left here to be a parentheses, and the parentheses indicates that I'm going to exclude 2 because I didn't have equality here. I still write a bracket on the right because I wanted to include pi because I have equality here. Oftentimes, the intervals we want to describe are infinite intervals. That is, they include a region of the real numbers that stretches off without bounds. In this case, I want to look at the set of all positive real numbers. Positive would exclude 0, but would include everything to the right of 0 on the real number line. So graphically, I'm going to exclude 0, but include everything to the right. Notice how I put a circle here, a little hole there, just to indicate that I'm skipping over 0 itself. 0 is neither positive nor negative. I would write that as an inequality by saying the set of all real numbers x, which is strictly greater than 0. And in interval notation, we would write this as 0 to infinity. This is just describing the fact that we have no bound to the right here. We never stop including real numbers. And notice I've put parentheses in both places. So I put a parentheses on the left here because I didn't have equality here. And we always will use a parentheses with infinity because we never quite reach the infinity. It's just a description of not putting any extra condition of what the upper bound for the interval is. If I want to look at the set of all non-positive numbers, just think carefully about that wording there. I'm saying all numbers which are not positive. 0 is not a positive number, so I would include 0, and I would include all the negative numbers to the left of 0 as well. And I've indicated that by putting a dot here as opposed to the hole that I had above. I could write that as an inequality by saying the set of all x which is less than or equal to 0. And as an interval, I would include 0, and I would go down towards negative infinity. This is just a description of saying everything to the left of 0. The minus side here is sort of saying this direction as opposed to the right. Again, parentheses on infinities, but we put the bracket here because it was equality here. If I wanted to describe the set of all real numbers itself, in other words, every possible value of x without restriction, I could write that in interval notation as well. And that would include the entire real number line, and we could just write that as an interval as minus infinity to infinity. Again, no brackets ever on infinities because we never quite get there